I am going to walk you through completing the post-lab for Lab 6, Ionic and Molecular Compounds. So this is going to start off with like a data table. It's got a list of all of the different compounds that you tested in the experiment. First thing that you need to do is classify whether each of these is ionic or molecular. And notice that KHP has been crossed off down here because you're not going to be filling this information out for KHP. So just for these compounds up here, your first thing is to classify whether it's ionic or molecular. This is not a yes or no question. Don't say yes here. They're all either ionic or molecular. It's asking you to categorize, is it ionic or is it molecular? Now, as a reminder, a molecular compound, we're going to define that as one that has no metal atoms in it at all. So looking at a periodic table, if you just get a periodic table handy, remember there's that kind of jagged line over on the right-hand side of the periodic table, and everything on the left of that jagged line is a metal. So if any of these formulas have a metal atom in them, they are going to be ionic. An ionic compound is a yes in terms of it does have a metal somewhere in the formula. So you'll look at all the atoms in these molecules. If one of them is a metal, then you'll say, okay, I know that that is ionic. And if none of them are metals, then you'll say it's molecular. The next thing that you need to do is determine how many total cations and anions are in each compound. Now, if it is a molecular compound, that means that it has 0 ions. So if you classify something as molecular, then you are also saying that it has 0 ions. Maybe I'll say that this is molecular. This may not be the right answer, in which case there would be 0 ions. For the ionic compounds, you're going to have at least 2 ions. There has to be one cation and one anion minimum. So for ionic, there is going to be a minimum of 2. And there's an example up here. This says if your compound was BaCl2, which is ionic, that contains 1 barium ion and it contains 2 chloride ions. So that would be a total of 3. So you're going to be counting up how many cations you have, how many anions you have. Now this is going to be a little bit tricky because some of these formulas have polyatomic ions in them, and polyatomic ions don't fall apart. They stay intact. So this particular compound has the carbonate CO3 2-, and that is counting as 1 anion, just 1. So it's going to be helpful when you're working on this to not only look at the periodic table, but you should also be looking at a table of polyatomic ions so that when you're looking at these formulas, you can find the polyatomic ions and you'll remember if you have a polyatomic ion, that means that it does not fall apart. Polyatomic ions don't fall apart. They are going to stay intact. So one of the common mistakes that students make on this is they'll say, let's say we say that NaHCO3 is ionic, and how many cations and anions are there? They'll just say 1, 2, 3, 4, 5, 6. There's 6. This question is not asking you how many atoms there are. There are 6 atoms, but there are not 6 ions. Okay, and then the last thing you're going to be filling in here is your conductivity. This is data that you will have obtained in lab. This is just going to be a variety of different numbers. So then we're going to go down to KHP. KHP is not potassium with hydrogen and the phosphorus atom. It's an abbreviation for a compound called potassium hydrogen phthalate. And it may or may not be a molecular compound or an ionic compound. So what you're going to do for KHP is you're going to look at the conductivity value that you obtained for KHP, and you're going to find a compound that has similar conductivity. So let's just say maybe our KHP conductivity is 7, and then we've got, I'm just going to make some random numbers up here. This is definitely not real data. So if this was my data and I saw the conductivity of KHP was a 7, I would say that's pretty close to the conductivity values for these 3 compounds. but it's pretty different from the conductivity value for these three. So whatever KHP is, in terms of is it ionic or molecular, it must be similar to these guys because it has similar conductivity. And so that's how you would go about making a determination of whether KHP is ionic or molecular. Now note that this question is not graded for accuracy. KHP is either ionic or molecular, but that's not what I'm trying to get you to discover in this experiment. Your grade for question number 4 here is completely based on whether you can match up the conductivity of KHP, match it reasonably with the conductivity of something in your data table, and use your data to support your conclusion. So for example, maybe you believe that KHP is a molecular compound, but your data says that KHP is an ionic compound. You would need to answer the question just by saying that according to my data, KHP does appear to be ionic, even though maybe from some other source you found online, you know that it's actually molecular, but the data says that it's in fact ionic. Now, none of what I just said there may be accurate. I'm just giving you like a hypothetical situation of like what you would do if your data was inconsistent with what you read on the internet. Again, the question is not being graded for accuracy. It's graded based on your ability to make a reasonable prediction using your data and your ability to explain and support your prediction.